Throughout the history of science, people have sought to understand the origin of the universe. One of the most widely accepted explanations is the Big Bang theory, which suggests that the universe began with a massive event, unfolding over billions of years. This idea has been supported by numerous studies and the work of thousands of scientists, who have provided evidence for how the universe came to be. However, with the advent of new technologies such as the James Webb Space Telescope, JWST, we are now being introduced to new perspectives that challenge our existing understanding. The James Webb Space Telescope has made an incredible discovery. It has identified 750 new galaxies. These galaxies are not what scientists expected, which is prompting us to rethink what we know about the universe. The telescope was designed to help us understand how galaxies formed, so it's no surprise that its findings are shaking up our current view of the universe's past. Traditionally, scientists believed the Big Bang theory was the best explanation for the origin of the universe. According to this theory, around 13.8 billion years ago, the universe began as a single, superdense point known as a singularity. This singularity was incredibly hot, hotter than anything we can measure or recreate. This idea stems from Albert Einstein's theory of general relativity, which suggests that all matter and energy in the universe were once compressed into an extremely small, dense space. As the universe expanded from this singularity, it began to cool and stretch, with stars, galaxies, and other structures forming over billions of years. The process of cosmic expansion, known as the Big Bang, also included a rapid period of inflation, during which the universe grew exponentially faster than the speed of light. This expansion flattened out the universe, allowing galaxies and other cosmic structures to form. However, the images from the JWST challenge some key aspects of the Big Bang theory. These pictures show galaxies that are smaller, smoother, older, and more numerous than expected, which doesn't align with what the theory predicts. For instance, as the universe expands, distant objects should appear larger. But the galaxies discovered by the JWST don't follow this rule. The Big Bang theory also suggests that in the early universe, all matter was packed into an extremely dense point. Yet, the new observations show galaxies that are much older and smoother than anticipated, conflicting with the idea that galaxies should have irregularities in structure due to their formation over time. One of the most surprising discoveries is the presence of galaxies that appear surprisingly mature. According to the Big Bang theory, galaxies should have developed through chaotic processes, with turbulence and irregularities. Yet the JWST images show galaxies that are unexpectedly smooth, without the usual turbulence one would expect from early universe structures. This raises questions about the processes that led to galaxy formation and challenges the assumption that the universe's early stages were characterized by chaos. Another aspect of these findings that contradicts the Big Bang theory is the number of galaxies discovered. The JWST has identified far more galaxies than scientists expected, calling into question the accuracy of the theory's predictions. The theory had suggested there should be fewer galaxies, and they should be distributed differently. However, the JWST images show a much larger and more varied number of galaxies than anticipated. Despite these surprises, some aspects of the Big Bang theory remain supported by the JWST's findings. The theory suggests that the universe began in an extremely hot and dense state and then expanded and cooled. The presence of galaxy clusters and large-scale structures, known as the cosmic web, continues to support the theory. These structures, shaped by gravity, align with the predictions of the Big Bang theory, showing that the universe has been expanding from a dense, hot state, with gravity playing a critical role in shaping the universe's structure. In conclusion, while the James Webb Space Telescope's discoveries have raised important questions about the Big Bang theory, they also continue to support key aspects of it. The findings suggest that the early universe may have been more complex than previously thought. The increased number of galaxies, their unusual smoothness, and their unexpected age challenge our assumptions about how galaxies formed. As our understanding of the universe continues to evolve, the discoveries made by the JWST are helping to refine our understanding of the cosmos and the forces that shaped it. The James Webb Space Telescope, JWST, has provided images that challenge our previous understanding of cosmic evolution, particularly the Big Bang theory. According to this theory, galaxies should have formed and grown through collisions and mergers. However, JWST observations contradict this expectation. If galaxies were merging as predicted, we would expect to see evidence of these collisions or dense areas within the galaxies. Instead, JWST images reveal a different picture. While the Big Bang theory is widely supported by evidence, such as the redshift of light from distant galaxies, the abundance of light elements like hydrogen and helium, and the cosmic microwave background (CMB) radiation, recent discoveries are raising questions. The CMB, a faint radiation detected in 1965, serves as a relic of the Big Bang, supporting the idea that the universe was once extremely hot and dense. Yet, JWST's findings suggest something different. One major surprise is the discovery of large galaxies existing hundreds of millions of years after the supposed Big Bang, which defies predictions that galaxies of such size shouldn't have been present that early in the universe's history. JWST images show a much greater abundance of large galaxies at redshifts greater than 10 than previously expected. This challenges the idea that the universe underwent a dark age, where galaxies would have been less common and smaller. Additionally, the Big Bang theory is associated with several incorrect predictions, such as estimates of helium and lithium abundances, which have been off by large margins. The theory also struggles to explain the absence of certain expected distortions in the observed size of distant objects. These inconsistencies have raised doubts about the theory's validity. Through JWST's infrared observations, astronomers can estimate the ages of stars in far-off galaxies, and some of these galaxies show stellar populations over 1 billion years old, contradicting the Big Bang theory's assertion that nothing should have existed before the supposed cosmic explosion. These findings, though significant, haven't been widely covered in the media, possibly due to the scientific orthodoxy effect, where challenging a well-established theory can result in backlash or accusations of undermining mainstream science. However, some alternative theories, such as the cyclic universe model, may provide a framework for understanding the new data, though they come with their own set of challenges and uncertainties. The continuous investigation of these anomalies is crucial for advancing our understanding of the universe. JWST has provided cosmologists with unprecedented insights, revealing the complexity of early galaxies and their surprising abundance. These discoveries suggest that galaxies may have formed much earlier than previously thought, and that star formation and chemical enrichment might have occurred at a faster pace. This challenges the timelines and processes that were believed to govern cosmic evolution. Furthermore, JWST images allow for a deeper understanding of galaxy formation and interaction. The observations challenge the notion that collisions and mergers were the driving forces behind galaxy growth in the early universe, suggesting instead that these processes might have been more orderly and less chaotic than the Big Bang theory predicted. The findings also suggest that the universe's early development may have followed a more structured path than previously believed, leading to a rethinking of how galaxies and cosmic structures evolved. As JWST continues to uncover new details, it's likely that more anomalies will emerge, further testing existing theories and paving the way for new models that might better explain the peculiarities we observe in the cosmos. This ongoing research is critical not only for evaluating the Big Bang theory but also for refining our overall understanding of the universe's origins and its complex history.